Hey, what's up, builders? So, welcome to course number 2 in our series on programming fundamentals. Last time we talked about variables and data types. Now we're going to take things to the next level and talk about a data structure called arrays. And we're also going to move on to the more advanced arrays, multi-dimension arrays, and then linked lists as well. So, first off, what is an array? An array is a collection of elements. So last time we talked about variables. So an example of that would be like a test score. We'd have a single integer variable to store the test score. But imagine if we need to store those grades for the entire year. So say there's a total of 5 tests. Well, instead of having 5 separate variables, we could have one variable called test scores. So let's hop onto our Sketchpad and take a look. So let's take a look at kind of how arrays are structured. So imagine we have a variable. We said to store a test score. Let's say I got a 87. Well, that's cool. That's one variable where we can store the test score. But like I said, if there's multiple, we don't really want to have, let's say there's 5. We don't really want to have 5 different variables for each test. It's much easier to work with the data when it's in a single variable, but it's structured that can house everything we need. So when we think of an array, think of it as multiple elements with a single variable. So let's say there are 5 tests throughout the year, and now I have multiple. So I got an 87 on the first one. Let's say I then got a 93 and 57, and I got my score back up on this one. Let's say we got a 96, and I finished out the year with an 88. Okay? So this is now an array where everything is stored in one variable. So the way this works is you have an index where you can traverse the array. So one thing to note is, so this is the first element, the second element, the third, fourth, and fifth. Now I'm going to number these for now while I explain this, and then we're going to get into how these look in the code. So you can see the first test score is 87, second is 93, and so on. And this I have labeled right now as number 1 because it's the first element. But in programming, everything is 0 based. So when you're going to that first element, it's actually not 1. What you're looking for is element 0. So I'm going to renumber these. I wanted to start out 1, 2, 3, 4, 5 so it makes more sense before getting too complicated. So in our array of 5 elements, you're accessing those elements with indexes 0 through 4. Okay? Now, when accessing these, we're going to have an iterator, which is going to point to the current element we're working with. So I'm going to hop into the code. So this is enough of an explanation of arrays for now. We're going to look at the code, and we're going to kind of go back and forth with explaining the code and then visualizing it on the board as well. Okay, so hop over to github.com/buildsharper and go into course 102. And again, if you need any help cloning a repo on your local, go back to our first course, course 0. That is a brief overview of Git. We also have a course completely dedicated to Git and all of the inner workings. So if you have any questions, go reference that video and then come back. So once you have course 102 pulled down your local, I'm going to open it up here in Visual Studio. Okay, so I've got our solution pulled up, buildsharper.course102, and you can see there's 3 apps. To start, we're going to start with app 1 and go into Program CS. So we can see First thing we're doing is we're declaring an array of quiz grades. So the syntax, these two brackets indicate that we're working with an array. And the first part is the type. So we've already covered integer types to store numeric values. And again, integers don't have decimal points. So in this case, we're using whole numbers for the test grades, just to keep it simple. So we have an array of integers called quiz grades, and now we're going to dimension it to have 5 elements. So whenever we declare a variable, it's allocating those 5 elements all at once. And we'll get into why that's important whenever we get to lists. But for now, let's keep it simple. We've got an array with 5 elements. And now, as we said, the first element is 0, not 1. Everything in programming is 0 based. So quiz grades 0, we're going to say we got an 87, a 94, 75, and so on. We've got all of our grades loaded up here. Now we're going to do a write line, my quiz grades. Now we've declared a variable here. Int quiz total is equal to 0. So what we're going to do is we're going to iterate through each of these grades, and we're going to total up all of the grades so that we can determine the average, right? Because the average grade is going to be all the grades added up divided by the number of grades, which in this case is 5. So we're going to use this variable. Now, we haven't covered loops yet, but I'm trying to kind of introduce you to code just so you can kind of familiarize yourself with it before we necessarily cover it. We're going to cover loops in a future course, but for now, you can see it and kind of experience it, and we'll talk our way through it without going into too much detail. So this is a for loop. So it's basically going to start with 0, and we're going to less than 5, which would be 4, right? Because for our 5 elements, we're going from 0 to 4. So this is a loop that's going to let us iterate through there. Now, we're going to do a console.writeLine quiz grades, which is our array variable, and then I want the element I, and then I'm going to add a % after it. So in this case, the first time it's going to come through, I is equal to 0. So give me quiz grades sub I, which is 0. So give me the 0 element of quiz grades and then display that with a percentage. So that's going to print out 87%. Okay? And then below that, like we said with quiz total, we're adding up all the quiz grades. So I'm saying take quiz grade 0 and add that to the total. This plus equals basically means take whatever quiz total is and add what's ever on the right side here. So it's accumulating. It's the equivalent of saying that quiz total equals quiz total plus quiz grades, right? So that's going to build upon itself. So it's going to start as 0, and you could think, okay, it's going to be equal to 0 plus, we said this is 87. So 0 plus 87 is 87. And 87 gets stored in quiz total. The next time around, where I equals 1, it would be 87 plus quiz grades sub 1, which would be 94. Now I can't do that math in my head, but it's going to keep accumulating that as we iterate through. This is the long form way to say it. Plus equals is more standard, and it's easier to read once you're used to the syntax. So quiz grade or quiz total plus equals quiz grades sub I. Now let me illustrate what this loop is doing. Let's go back to our board. Okay, so we're back on our board and we have our array of quiz grades. Now, to illustrate our loop, I want to take a look at the indexer. So imagine this is a little pointer, so if I can turn this. Okay. And this is I, so let's add an I to this guy. I. So the first iteration of our loop, I is 0, right? So it's pointing to this 87. So that's when we were displaying 87% and then adding it to the total. Now, let's switch back to our code view. And the way this works with a for loop, we're going to have our initial value. So we said I is 0, as we just illustrated. Then, if this condition is true, it continues to run this code. So, I is equal to 0. Is 0 less than 5? Yes, that's true. So it's going to run this code. After this executes, it's going to come back and execute this line of code. I++. What that means is it's going to iterate that value. I, in this case, is an integer. The next value of I, if it's currently equal to 0, the next value to I as an integer is 1. So now I is 1. And then it's going to go back to this check. Is 1 less than 5? Yes, it is. So it's going to execute this. Then we're going back up here. Now I is 1. I++ means now we're at 2. And it's going to evaluate. Is 2 less than 5? Yes, that's true. So it's going to execute this. And so on. Then we go to 3, and then we go to 4. When we hit 4, now 4 is going to be equal to 5. Now we evaluate here. Is 5 less than 5? No, that's false. So we fall out of this block. Between curly braces is known as a block of code. We're going to fall out of this block and go on to the next line. Now let's go back into our board and illustrate what that loop looks like. Okay, so as we said, with a for loop, it's evaluating, we're incrementing I until the check is no longer true. And that check was if I is less than 5. So we do an I++, which means it goes from 0 to 1. Now we display the 93. We add it to our quiz total and move to the next. I++. I was 1, now it's 2. Is 2 less than 5? Yes. So we're going to display 57 and add it to our quiz total. I++. Now I is 3. Is 3 less than 5? Yes. So we're displaying 96 and adding it to our quiz total. I++, 3 is now equal to 4. Is 4 less than 5? Yes. So display the 88 and add it to our quiz total. Now we do an I++ on 4, and now I is 5. But we can see now we're outside the bounds of our array. So if this code were to run, it would actually blow up. It would have an exception because we've stepped outside the bounds of the array. So that's why we did that check to say if it's less than 5, right here, this less than 5. That safeguarded us against going outside the bounds of the array. If I happen to say if this is less than or equal to 5, now in this case, it's going to continue executing this. It's going to say, yep, 5 is less than or equal to 5. Now I want to go display. Well, there's nothing there. So you're going to have a runtime error of that you're stepping outside the bounds of the array. So that's one thing that's important to remember when working with arrays is everything is dimensioned up front so that we know the size of the array. But we have to stay within those bounds when working with it. Okay, so back in Visual Studio, I can see now that we've displayed our grades and we've accumulated up our quiz total, we're going to calculate our average. So we're going to have a double quiz average, and that's going to equal the quiz total divided by 5. Now you can see this syntax here where I'm saying double in parentheses 5. We haven't covered it yet, but this is known as casting. So we're taking this 5, which by default is an integer. And again, we said integers don't have decimals. But when calculating an average, most of the time we do want a decimal. So in .NET, if I divide two integers, it's going to give me an integer. But I need a double. So I'm taking this integer value, quiz total, and again, we declared it up here, an integer. So we're going to take that and divide it by 5. But I need a double value out of it. So that's why I'm casting 5 as a double. So it's essentially saying it's equal to 5.0, which is a double. So that my result is in decimal form. So I'm going to display it on this line. The average quiz grade equals quiz average percent, and I'm awaiting the user's input just so they can view the grades and then press enter. That's the first way that we're going to illustrate these grades. Is we've created an array with 5 elements. We've added these elements at index 0, 1, 2, 3, and so on. And then we've looped through with a for loop to display those grades and then to add them up with the quiz total and then display the average. So that's the first way of doing things. Let's take a look at this. Let's run this app real quick and then we'll go into detail on the test grades, which I use as a different example of a different way to do things. But let's run it and look at it first. Ha! And actually, this is good. This is a good learning. So remember we changed this from less than 5 to less than or equal to 5. And as we said, this is going to now step outside the bounds of the array. So indeed, we did get an exception, system.indexOutOfRange exception. Index was outside the bounds of the array. Now that's a really obscure way to say we have tried to access element 6 of a 5-element array. Does that make sense? So in order to fix this, I'm going to stop and move this back to less than 5. Now let's run it. Okay, so now we can see my quiz grades, 87%, 94, 75, and it calculated the average quiz grade, 88.8. So that's the first part. Now, this second part, if I press enter, it's going to display my test grades. Let's see the difference between how I stored and accessed my quiz grades versus how I store and access my test grades. Okay, so again, quiz grades, we added these grades one by one via the index. So I said grade 0 is this, grade 1 is this, and then I used a for loop to iterate through that array. Now, for my test grades, I did this a little different. You can see this syntax is a little different, but it's also more concise. So I have an array of integers. So integer is the type. The brackets indicate that it's an array called test grades. And now I have this comma-separated list of grades. This is much easier to visualize. If I know up front what all of my values are, I can initialize it with all those values. Now, you may not know all the test grades up front, so that wouldn't necessarily be a good use case for this. But if it's an array of elements that we do know the value for, you can initialize it in one line. So you can see this is one line of code where this took 6 lines of code. And essentially it gets us the same place. So this is a little bit conciser way of initializing our array. Now, instead of a for loop, again, we used a for loop up here. For int I equals 0, while I is less than 5, I plus plus. And this allowed us to index through our array and access each one of those elements. Down here, I'm doing a for each. This is essentially doing the same thing without having to have the nitty-gritty details of let's create an integer, start it at 0, make sure it's less than 5, and then iterate I++. This is a little bit more human readable. For each int test grade in test grades. So test grades is our array. And as we define it up here, it has our 5 elements. Now we're saying for each test grade in that array. So it's grabbing each element one by one, and we can access it with a variable called test grade. So down here inside the loop, I'm doing the same thing. We're just writing out the test grade with a %, and we're totaling up our test grades. So we have this integer test grade, or test total, equal to 0, and then we're doing that plus equal for each test grade. So we're adding them up as we go. And then finally, we're doing the test average is equal to the test total divided by 5, casted as a double, so that we get a double back. Okay? And then finally, it's got the test score. So let's run this one more time now that we know how everything's built. Okay? So again, there's my quiz grades. And there's my test grades. So visually, you can see these two arrays are very similar in how they're displayed. But structurally, in the back end, we did things differently. Okay, so that gets you started with arrays. But let's say you needed to store more elements, maybe 2 dimensions of elements. So we just covered arrays and the concept of having multiple elements of a certain type to store multiple values of data. So in the last example, we used test scores. But what if you have to store more dimensional data? So for example, think of the game Battleship. So with Battleship, it's like a grid, right? Where there's letters on one side and there's numbers across the top, to where you can give a row and column where you're making a guess where the person's ship is. This is a great example of a 2D array. So I'm going to hop back on the board and kind of visualize what a 2-dimensional array looks like. Okay, so I'm going to clear out our previous example. And like I said, the game Battleship, where you place your ships on a 2D grid, and then the other player has to guess via element where your ship is located. So they're going to do like D7 and then guess that your ship is on that element. So let's pull up a grid here. And let's make it a little bit bigger. Let's say it's 5 by 5. Oops. Now before, in our first example, we were just storing 5 elements. You can think of that as the first row of this grid, right? There's 0, 1, 2, 3, and 4. So there's 5 elements. But now we're saying there's 2 dimensions to this. We have what are now columns. This is column 0, column 1, column 2, 3, and 4. And then we have rows. So this is row 0, row 1, 2, 3, and 4, making this a 5 by 5 2-dimensional array. So now, going back to our Battleship example, let's say we have our letters on this side as our rows. So this would be A, B, C, D, and E. And then across the top, we're going to have 1, 2, 3, 4, and 5. And let's say we have a ship here. So if I were to have an accurate guess of where this ship might be, if I guessed C4, well, that's a hit because that's where my ship is. Now, as we said, in programming, everything is zero-based. And our arrays don't actually have letters, it's all integers as the index. So let's change this to look like something in programming. So 1, 2, 3, 0, 1, 2, 3, 4 are our columns. And then these would be 0, 1, 2, 3, 4. So now our guess of 2, 3 would be where the element is. Because the first number we're going to give is the row. And then we're going to give the column. All right, so to wrap our heads around two-dimensional arrays, I want to hop back and forth between the board and Visual Studio. So let's go take a look at app number 2. Okay, so I'm going to set this as our start project. Let's go into Program CS for app number 2. Now, this declaration looks a little bit different. If you look at with app 1, when we declared our quiz grades, we said it was an integer, and we said the square brackets indicate that it's an array. We give it a name, and then we initialize it. In this case, you can see I'm creating an integer array. It's got the square brackets, but there's a comma in there. And that comma indicates that I'm going to have multiple dimensions to this array. In this case, there's 2. So I've got rows, as we said, and we have columns. So in this case, I'm creating a 10 by 10 array. And I'm initializing it in line with all of these values. So in this case, we're creating the player 1 board. For this example, I had 0 indicate water, and the numbers would indicate a ship. So like ship 1 is placed here, ship 4 is down here, 2, and then I've got 5. So I initialized the two-dimensional array with all the water and the ships. But then to illustrate that we can also access these elements inline, I wanted to add ship 3 to the board manually. So ship 3 is now going on to row 0, column 9. So row 0 would be this guy here, and then 9, remember, it's 0-based. So it's a 10 by 10 array. So 9 is going to be the last column. So this element here would then turn into a 3. And then row 1, element 9 would be the next 3. And then row 2, column 9 would be a 3. So we're going to have ship 3 right up here in that corner. Okay? Now, we've allocated the memory for our two-dimensional array. We're pretending it's a battleship game that we're building. But now I want to display the board. To do that, I need what's called a nested for loop. So the first loop is going to be our rows. So we're iterating through 0, 1, 2. So let's go back to the board and illustrate this. Okay, so in our last example, we used an arrow to indicate where our for loop indexer was, right? So as I said, there's going to be a nested loop where we say we're on row 1, row 2, row 3, and so on. So that's our first loop. And this is I. So let's go name this guy I. Now, we need another for loop or another indexer. So let's copy this, point it, if I can figure out how to rotate it. There it goes. And this is going to be J. So, loop I is going to take us through each row. Loop J is going to take us through each column. So when drawing our 2D array, we're going to be using a conjunction of these two for loops. So let's visualize. So if I'm at I equals 0 and J equals 0, let me clear out this X just to simplify things. If I'm at I0 and J0, now I'm at this element. And that would be the first thing I draw. Now, let's go back to Visual Studio. So in Visual Studio, you can see we have this outer loop of I. That's going to be our rows. The inner loop is going to be our columns. So, but remember, it evaluates this part first, then the inner code. It's the same thing with a nested loop. It's going to evaluate this and then do the inner code. But it's going to continue this loop before moving on to the next row. So, on row 0, I'm going to go through element 0, element 1, element 2, and so on. Once I've traversed that entire row, I move to the next row. So let's visualize that on the board, okay? So as I said, we're starting here at row 0, column 0, but as that J++ moves from element 0, it's going to go to element 1, element 2, element 3, and 4. Now I hit 5, and that check of is J less than 5 is now false. So it falls out of that loop. And J is now back at 0. But we've fallen into our, I'm going to go back into Visual Studio. Now we've fallen out of our J check. So we're going to write a /r/n, which is just a new line. So it's going to write a new line. But then we're now back here where we do I++, which means we're moving on to the next row. So back to the board. Now I is at 1. And now we're here. And we're going to go through and go I0, goes to 1, to 2, and so on, till we get through that loop. And again, now we move to the next row. J goes back to 0. And now we're here. Does that make sense? So, it's actually, there's a lot of computation in displaying or iterating through a two-dimensional array. As you can see, we have to go element by element, row by row, and column by column. So we index every element in the array. So in this case, it's 5 by 5. So that's 25 elements that it's going to have to iterate through. And then back here, For our battleship board, it's a 10 by 10, which is 100 elements it's having to access. So let's run our app. Okay, so we can see there's no logic to this app. It doesn't actually have any input. We're just displaying this two-dimensional array of data. And we can see all the ships we placed are there, in addition to ship number 3, which we added manually outside of the initialization of the two-dimensional array. So that's two-dimensional arrays. Basically, we have now a way to store multiple dimensions of data. And again, this is when we already know the size of the data. So we said for test scores, there were 5 test scores. And let's say we wanted a separate row for each student, and we know there's 10 students. So that would be a 10 by 5 array. So when it's initialized, we know the exact size of that array, which means that .NET is going to allocate that 10 by 5 array into memory up front because it already knows the footprint it's going to need for that variable. But what if we don't know the size of something? Let's say we wanted to store like a grocery list. We wanted to store multiple items, but we don't know how long the list is going to be. Because as I think of more things we need from the grocery store, I'm going to add to the list. I'm not going to know up front, I have to go get 10 things from the grocery store, right? So that's where linked lists comes in. Linked lists essentially allow us to have an array data structure, but it can grow dynamically as we run the application. So let's go back to the board. Okay, so using the linked list data type, let's pretend we're going to build a list of groceries. So let's say the first thing on our list is bread. The way a linked list works is essentially it starts with one element and it has a pointer to the next element. So when it allocates the variable into memory, it doesn't have to know the complete size of the array. So essentially, I need to know where's the first element and how do I get to the next element. Now I can say, now I need milk. So I can add, if I can spell, milk, and eggs. Now, I've created an array with 3 elements: bread, milk, and eggs. I didn't know up front that my list would only be 3 items. I knew it'd be at least one, and it would be a list. So let's hop back into Visual Studio and let's take a look at the third app. Okay, so I'm in Visual Studio. I'm going to set up App 3 as my start project, and let's dig into the program CS. Okay, so you can see I'm now creating a variable called grocery list, and it is a new list data structure of type string. So this list is what's called a generic. It is a data type. It's a linked list, as we showed on the board, where it has, it knows the first element, and it knows that there's a pointer to the next element, and so on. So it can store an unlimited amount of elements, and I don't have to know how big the array is going to be up front. And then, as we can see, this is what's called being templatized between these two greater than, less than signs. It's going to be of type string, because again, we're making a grocery list, so we aren't going to store 1, 2, 3, 4, 5. We're going to store milk, bread, eggs, etc. Now, again, with these programs, I'm trying to introduce you to new data structures as we go, and new elements of coding, just so you've seen it. In future courses, we'll go into detail on how these work, but much like we did the for loop and the for each loop, we now have a while loop. So let's take a look. Okay, so we have our grocery list. Now we're defining a variable called done and setting it to false. That means that this is going to be a Boolean variable that can either be true or false. So here on line 9, we have what's called a while loop. So we covered for loops and for each loops. Now this is a while loop. And it basically is going to continue this block of code as long as this is true. Now we can see we set done to false, but right here in the while loop there's this exclamation point before done. The exclamation point is a not. It means not whatever this evaluates to. Well, done is equal to false. So not false is true. So while this is not done, continue running this logic. And it's going to say enter a grocery item and type done when finished. So we're asking the user to input a grocery item. So we're doing a console.readline. Whatever they enter goes into this item variable. Now, if this item variable, and here's that not again. So if it's not equal to null, which a null is an empty variable. Now the reason we're checking against null is because we can't run methods against null objects. We'll get another exception and it'll be a runtime error where we can't actually perform things on a null variable. For instance, we're doing a check here if item dot toUpper, so item is a string, whatever they type in, toUpper is going to make it uppercase. So if I said bread, lowercase, toUpper is going to make it uppercase bread. Now I'm trimming it, which is going to trim out any extra spaces. So if I said bread space 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 enter, it's going to cut that down. And I'm comparing it to done. So if they type in done, now I'm setting this done variable to true. And we can see it highlights it up here in our while loop. If done is true, it's going to break out of this while loop. If they didn't type done, I'm going to add it to the grocery list, right? So that's what we're doing. We're going to continuously ask them to add more grocery items until they're done. When they type done, they're finished with their list. So I'm going to clear the screen and write out my grocery list. Now we're again doing a for each item in the grocery list. Do a console.writeLine. I'm just going to add a little dash before the item name to kind of visually give it kind of a bulleted list look. And then say press any key to continue. So let's run this and take a look. So let's make our grocery list. Enter a grocery item, type done when finished. So let's say bread, milk, cheese, eggs, jelly, peanut butter, and one last item. Let's get some grapes. And I think we're done. So I'm going to type done on my grocery list. And look at that. There we got bread, milk, cheese, eggs, jelly, peanut butter, and grapes. So what we've done, we've created a variable that's going to be a list of strings. We've then introduced the while loop and allowed the user to input items and adding it to that grocery list. And then finally, we clear the screen and display the list. So that's going to do it. We now have the concept of arrays. We've introduced variables and data types, and now we have a data structure called arrays, where we can store multiple elements of a single type. For example, before we had a single grade for a student. Then we had an array with 5 elements, so we could store up to 5 grades, right? Then we had a 2D array, where we first visualized it as a battleship game, where we had rows and columns where we could store our ships. But we could also use that two-dimensional array to store multiple student records. And then finally, we covered linked list, where we need to store multiple elements, but we don't necessarily know the size up front. And a good example of this was the grocery list. I know I'm going to need a list of groceries, and I want to store that in a single variable. And using the list data structure in .NET is the easiest way to do that. So that's all for now. We'll see you next time.